is going to give you what?
Hydronium and chlorine.
Hydronium. Let's say that this is an equilibrium, okay? This is going to act like the what? Like the acid, and this is going to act like the base. So this is the acid, and this is the base. So this will become H3O plus Cl minus. What is this Cl minus called?
The conjugate base.
Conjugate base. Most things that are negatively charged or have an electron pair are bases, yes? And so this is the conjugate base. Most things that are positively charged are acids, so this is the conjugate acid. I expect you to find what the conjugate base and the conjugate acids of things are, like you did in 1046, but I don't want to review this, okay? Because I got tired of doing this already. Okay, you'll make that with water act as an acid, and in another equation as a base. Right, both equations. That as an acid, and this as a base. That's both. So in one, this will be the acid, and in the other one, the base.
Can you read what you wrote?
What do you mean, read what I wrote?
The computer
H?
is like,
The computer's in the middle? Oops, whose cell phone was that? I broke it. Okay, if this acts like the acid, we're going to add water to it, yes?
Yes, sir.
And what is this going to do?
SO4 minus plus hydronium.
That acted like the acid, SO4, 2
2
minus.
minus, sorry. Yeah.
Okay? You generate a minus after you do that.
That's right.
2 minus.
That's right.
So this will be the acid, and this is going to be
The conjugate base.
conjugate base. Very nice. Plus
Hydronium.
H3O plus, and this is the conjugate acid. Yeah, Pierce, you're gonna get this right on this test, huh? Okay, and now this is going to act like the base, and
H2SO4
H2SO4
plus
plus
OH.
OH minus. H2SO4 is what?
Not the conjugate
conjugate acid.
acid.
Conjugate acid.
Conjugate acid. And this is
Conjugate base.
conjugate base. Very nice. So strong acids are 100% ionized, yes?
Erase the last line, please.
Strong acids are 100% ionized. You should remember that from 1046 or 1045. I'm not going to repeat them. There are seven of them. Okay? If they are weak acids, then they have this thing here. Yes? So let's say that they are weak acids. How is this going to look like? H3O plus plus
A minus.
A minus. If they are weak acids, they will have something called an equilibrium constant. This equilibrium constant is called Ka.
Nice try.
And you thought you were going to get away, huh?
No ice tray.
Sure.
Oh my goodness.
The equilibrium constant is the concentration of the products divided by reactants. H2O is not included because H2O is
Liquid.
liquid. So this is aqueous, this is liquid, aqueous, and aqueous. Now don't you worry about it, we're not doing ice charts, okay? But you do have to know that the higher the Ka, the what the acid?
The stronger.
The stronger the acid. Now pKa is the negative log of Ka. So the lower the pKa,
Yeah, stronger the acid.
stronger the acid. That's what we have to know. You like that better, yes?
Yeah.
Very much so.
Okay. All right, that's good. We are going to compare pKa's, and I kind of already explained this to you in 1046 in preparation for this class. Things that have pKa's that are less than 1, okay, they're strong acids. pKa's of less than 1 are strong acids. Things that have pKa's from 1 to 3 are moderate acids.
1, 2, 3 moderate, and what was the other one?
Less than 1 strong.
Strong, moderate, and from 3 to 5, they're weak acids. And from 5, let's say, to 16, they're very weak. And anything higher than that, they are extremely weak.
Wait, you said 1 to 3 and then 3 to 5?
Yeah.
Okay, so then what if it's 3?
3 to 5.
You get what I'm saying, right?
It's never 3. It's 2.99 or 3.01.
Oh,
Okay, so by looking at the pKa of an acid, you kind of know whether it is very strong or weak or whatever it is. Okay? Now, if I have, let's say, pKa of that is 38. And the pKa of this is around 44. Which one is a stronger acid? The first one is a stronger acid. Now I want you to draw the conjugate base of each of those. And I want you to tell me which one is the stronger conjugate base. I don't want you to say. I don't want you to say. Keep it to yourself. Draw it and say, is this? So what are you guys drawing or writing?
No, we finished.
No idea.
We finished. So we should keep it to ourselves.
No, I don't want you to write equations, my friends. Draw the conjugate base of this
Yeah.
and tell me which one is a stronger base.
Yeah.
Don't know where to see.
The strongest base comes from the weaker.
I said keep it to yourself.
You have no clue. That's yourself too.
Have you noticed?
Some people got issues, huh? You don't remember what?
How to draw the conjugate base. You have no clue.
The conjugate base of this acid, you take away an H plus.
Yeah, but
Yeah.
that looked wrong. He's gonna give you ammonium and OH minus.
What to explain to you?
H formula.
Minus.
Oh, you want me to say write it?
But you said draw, so.
This is a drawing.
That is a drawing.
This is a drawing, yeah, that's a
That
drawing.
is not drawing, Garcia.
What's a
That's
drawing?
what the Lewis structure.
I am sorry to tell you,
That is a
it is a drawing.
Well, I guess technically you did draw a letter, so.
I mean, it's not typed, yes? I didn't type it.
You drew it?
I did a work of art, so this is a drawing. And this one is what? That one is like that. And of course, the electron pair is where? The electron pair is on the carbon. So which one is the stronger base of those two?
The bottom.
This is the stronger base. Stronger base. Because?
The stronger, that's the strongest.
BC, can we put BC?
Yes.
Yeah.
What does BC mean?
Because
All right. I thought it was before Christ, but then that's your... You say it's because. It's a new lingo here. So BC, because
weaker acid.
it comes from the weaker acid.
Is there a difference between calling it just a base or calling it a conjugate base?
Is there a difference? Yeah, one implies that it's coming from somewhere, and the other one implies that it
It's
is
just
basic.
basic.
Yeah.
Okay. So for here, we could use it interchangeably then?
Yeah. Once you have it, that's it. It's a conjugate base of this, but it
But it's
is
still
a base.
its own, yeah, okay.
Okay, so if you have an equation and you have on the two sides, you need to determine whether the equation is going to the right or to the left.
Don't erase the bottom.
Scary, this class. Is that it?
But then this is the structure.
See, I tried doing that and I didn't get how to do it. Like, I didn't understand that.
You mean you read the book ahead of time?
Does that have anything to do with like the protonization or whatever?
Protonization.
Yeah, that.
Protonation.
Yeah. What? Yes, I guess that. I don't know, but it was something like that, and I didn't understand why.
That's okay, you will after I explain. I'm good like that.
Oh, this is the arrow formula, right?
No, this is not arrow. I mean, we could do, you want to do arrow
No,
formalism?
no, no, no.
Okay, we'll do both, okay? Since you, by popular demand. So, on the test, this is going to look like this. Predict the direction of the equation. So what you have to say is whether this goes forward or reverse. Okay? And I guess that we can do show arrow formalism. It's good practice. Now, in order for you to know the direction of this equation or the direction of this thing we have written here, you have to know the pKa's, which one is more acidic and which one is more basic. You have to know either the two bases or the two acids. Okay? And it will go away from the direction of whatever is stronger. So the stronger thing is going to act like it. So let's say a pKa of this is about 16. And the pKa of this, let's say, is 4. Where is the equation going to go? To the right or to the left?
Left.
To the right.
To the right, right? Doesn't it follow the stronger?
It has the stronger acid.
The stronger acid, right?
Conjugate goes whatever stronger.
Oh, yeah.
Oh, yeah, it's over to the left.
Because it has
Because the conjugate base of a strong, okay, yeah.
Where is it going to go?
Yes.
But I just told you where it was going to go.
Wait, where is it going to go? I didn't hear.
Oh, wait.
I was
Because I haven't said the answer yet.
No, what you said before.
It goes to the stronger acid.
It will go away. Whatever is stronger, it will go the opposite way.
Okay, so it's going to the left.
So it's going to the left, reverse.
Because this is a stronger acid, it will act like a what?
Bing.
Conjugate base?
Because that is a stronger acid, it is going to act like the
Weak base?
acid.
It's gonna leave.
The stronger acid is going to act like the acid, and it will give away the H plus to become this. So it's going to come this way, away from whatever is stronger. Away from whatever is stronger, because it's going to act like it is. So if it is a stronger acid, what is it going to do? Act like
And that's
the acid, and the reaction will go opposite way.
opposite of it.
Okay.
Yes?
So by following, it just goes in reverse or
What?
you said it follows the strongest acid, right?
Goes
I know,
away
you're
from the
confusing me.
strongest acid, right?
Don't confuse me. Why are you confusing me?
It moves
So-
away, it doesn't
Goes
follow.
away from the.
I don't know what you're talking about. So if we're going to do the arrow formalism, this is going to look like this. An electron pair from here is going to do what? Arrow formalism. An electron is going to attack something. Yes? Because electrons are the ones doing all the attack.
Right.
Yes or no?
Yeah.
The electron is going to attack whatever is what?
Missing.
What charge?
Positive
Positive
charge.
charge.
So what is positive is here. This is the acidic part of this thing. Because of a difference in electronegativity and because this is stabilized by resonance, which makes this more acidic. So this is going to go like this. and it is going to take the proton naked by itself, and it's going to leave behind the 2 electrons. The oxygen goes, you're not taking the electrons. You want to go? Go. You can, some of you guys can relate to that, yes? I'm going to take this stuff, but you can go. You can go with your boyfriend. So that's called the arrow formalism. And what happens after that is that this becomes this. Yes or no? It became this thing. And this thing is resonance stabilized because I can put the 2 electrons there, and those 2 can go that way, and this gives me this resonance structure. And everything that is resonance stabilized is good. So all carboxylic acids are acids because they are resonance stabilized. At least in part, yes? You want to do another one?
Yeah.
Why do you want to do so many?
To know more.
The negative charge is where here? On the hydrogen or on the nitrogen?
Nitrogen.
It's on the nitrogen. I expect everybody to know it's on the nitrogen, okay? And I expect everybody from now on to know that whenever you see NH2 next to a metal, what is it going to be? Does that exist by itself? Does this exist by itself? No. That does not exist by itself. What exists is something like this. Na, NH2.
Yeah.
You have to know that this is a base from now on.
Are you going to give us the pKa?
I am not. I already expect, I have expectations of you guys.
Okay.
I have already given the pKa's. Where is it going to go? To the right or to the left? Hello?
Right.
You kind of more or less need to know the strength of acids. Okay? There is a table in the book. I want you to read it. and I want you to kind of know the stuff in that table. It's on page 165. It shows you the pKa's of common things, and the common things you have to know is a carboxylic acid, is it acidic or no? Hello? Yes, a carboxylic acid is acidic. Is a carboxylic acid more acidic or less acidic than water? More acidic than water, of course. That's why it's called a carboxylic acid. Don't let them lie to you. Okay? An alcohol will have, okay, let's do the problem before I give it away. So I expect you to know that the pKa of this is how much? 38. Around there. And I expect you to know that the pKa of this is?
44.
What? You're crazy. What the hell?
You added the OH.
Well, that thing that you see here is the same as that one, if you noticed. So this is 16, around 16, okay? Who cares what it is? Where is it going to go?
To the left.
To the left? Direction is going to go this way?
Yes.
Why is it going to go this way?
Right?
Because this is the stronger acid. Which means this is the what?
The weaker.
That means that's the.
Compared to this and this, which one is the stronger base?
The one on the
That one,
This one, no.
This one.
That one is. Why that one?
The strong.
The strong.
Oh, yeah, because it's the conjugate.
It's the conjugate. That's
Maybe you never understood what I meant. Stronger goes away from stronger. Yes, stronger, stronger. Of course, this is the stronger base because this comes from a weaker acid.
Yeah.
I mean, Okay, so here's the idea. Carboxylic acids, and this is why I want you to look at this chart. Okay? That chart. Carboxylic acid, it has the acids and the conjugate bases. In general, carboxylic acids are weak acids. And of course, you have the strong acids, yes? Which is 7 of them. You memorize them. Then you have carboxylic acids, which are weak acids. And then you have water. And then you have alcohols. And alcohols are these here. It doesn't matter what it is. If it has an OH, the pKa is around that. Okay? 16, 17, 15. That's the pKa of acids. After that comes things like triple bonds. This hydrogen on a triple bond is about 25. And after that comes things, so carbons that have a triple bond. And then after that comes things like containing nitrogen in the 30s. And then after that comes sp3 hybridized carbons. And these are in the 40s. Okay? Yes? Hello?
Yes.
Carboxylic acids, water, alcohols, triple bonds, well, double bonds, and then ammonia, nitrogen-containing compounds, and single bonds on carbons. Okay? Guys, yes or no?
Yes.
Did you guys pass around the attendance today?
No.
Which one is a stronger acid?
All the way to the right.
Which one is a stronger acid?
All the way to the right.
This one is a stronger acid. They are all what type of? They are all alcohols. Okay, they're all alcohols. But this one has this fluorine here. And this fluorine is withdrawing electron density from this bond that you see here, weakening it. So because it needs so many electrons, it is pulling electron density from here, and from there. And by pulling electron density, it's polarizing that more. Okay? Yes or no?
Yes.
I ask you questions like that on the test. And here's another one. What do you mean so fast?
They got nothing done, they bring.
Writing it down and you take it off. Exactly.
Shots fired.
Which one is more acidic?
The first one.
Top one? First one.
Which one?
First one.
This one, because the CF3 is
This is a lower-
closer
So then-
to the OH. Okay? I'm going to erase it. How do I make that more acidic without using fluorine?
Change the oxygen to chlorine.
So write this stuff down and write at least one example in which you can make that more acidic without using an F. Don't say anything, write it down. You're suggesting people to do it. Okay guys, after this we're going to go into a new chapter. Why are you guys staring at me? It looks weird that we go into a new chapter? Or you want more? of this.
It's amazing.
You want more?
The new chapter,
Wait,
you have
up
to
to
test.
what is, the test
Up to this right now.
right now?
The new chapter will not count.
The new chapter will not be on the test, so you can close your eyes.
Oh, that sounds like a plan.
Wait, why what? Say it, just say it, I'm gonna tell you why.
Why start the new chapter?
Because if we don't, we don't finish the course on time, or I have to speed up,
No.
and you don't want me to speed up.
No.
So how do I make this more acidic without using fluorine? What do I do?
Go to chlorine.
Put chlorines on it, which is the next electronegative element after that. So where do I put them?
As closest to the OH as possible.
As close to this group as possible. I can't put it here.
No.
I can't put it there. I gotta put it here. This is more acidic than the one before, and this is even more acidic than the one before. So by placing chlorines or fluorines on things, you make them more acidic.
Okay.
Now the next chapter is called Chirality. And how would you spell that? That is called chiro. Okay? Some of you like to call it chiro. Call it whatever you want. Okay? But that's the word. And I am not going to give you details of what that is now. I am just going to show you this week how to draw it. And next week, after the test, we are going to continue with this. Okay? This is not on next week's exam. So put a line here right now and say,
Second test.
not on the test.
Second test.
Or put an arrow showing up and say, up, first test. Is that clear?
That's chapter 3?
What?
That's chapter 3?
Yeah, this is chapter 3.